Let us take two beakers. In the left hand side beaker we have 1 molar zinc sulfate solution, and in the right hand side beaker we have 1 molar copper sulfate solution. Zinc rod is dipped into the zinc sulfate solution and copper rod is dipped into the copper sulfate solution. Zinc rod acts as the anode and the copper rod acts as the cathode. These two rods are connected through an external electrical circuit that contains a digital voltmeter. The two beakers are connected using salt bridge. This setup is called an electrochemical cell. An electrochemical cell converts chemical energy into electrical energy. At the zinc anode, oxidation occurs, that is, zinc gives zinc 2 plus 2 electrons. These 2 electrons travel through the external circuit to the cathode. As a result, a potential difference of about 1.1 volt is produced. At the cathode, the copper ions present in the copper sulfate solution combined with these 2 electrons and get reduced. Copper is deposited on the cathode. That is, copper 2 plus 2 electrons gives copper. Because the reduction occurs at the cathode, the size of the copper cathode increases. Meanwhile, in the anode compartment, the zinc anode gradually decreases in size because zinc atoms are continuously oxidized and dissolved into the solution. As the cell operates, an electrical charge imbalance develops in the two compartments. To maintain electrical neutrality, the salt bridge functions by allowing the sulfate ions to move toward the anode compartment and sodium ion to move toward the cathode compartment, thereby neutralizing the charge imbalance. Eventually, the flow of current stops. At this stage, the Daniell cell needs to be recharged. To recharge it, we connect an external battery of about 1.5 volt across the circuit. Now the cathode becomes the anode and the anode becomes the cathode. However, their physical signs do not change. Only their electrochemical roles are reversed. This setup is now called an electrolytic cell. In this case, electrical energy is utilized to produce chemical energy. At the copper rod, oxidation occurs, that is, copper gives copper 2 plus 2 electrons. These electrons travel through the external circuit to the cathode, which is now the zinc rod. At the cathode, the zinc 2 plus ions present in the zinc sulfate solution accept these 2 electrons and get reduced. Now you can see the reduction reaction of zinc 2 plus ions. That is, zinc 2 plus 2 electrons gives zinc. The reduced zinc is deposited on the cathode. As a result, the size of the zinc rod increases while the size of the copper rod decreases. The excess sulfate ions and sodium ions move through the salt bridge as required, restoring the ionic balance and gradually returning the system to its original state. At this point, the Daniell cell has been regenerated.